I'm head of laser and soft X-ray diagnostics. So that means that my team and I work on all of the laser-based diagnostics and also diagnostics that collect the lower energy X-ray signals from the plasma. And one of those electron diagnostics, which is actually a new system we're just commissioning here on SD40, is Thomson Scattering. Thomson Scattering is really like a fancy speed gun for electrons. You fire a high power laser into the plasma, and most of the energy goes straight through the plasma, but a tiny, tiny fraction is scattered. And that interaction between the laser light and the electrons causes the laser wavelength to change. And if you can collect that scattered light and you can analyze the wavelength, then you can calculate from that the temperature of the electrons in the plasma. And also the brightness of that scattered signal, so like how much of the light scatters, also tells you about the density of the plasma. The fusion fuel that we would use in a spherical tokamak is deuterium and tritium ions. These are both positive, so they want to repel each other. You have to do a lot of work to force them together. So having a high temperature, high density, and a long amount of time when they're swirling around in this energetic plasma all increases the probability and the likelihood that they can actually be forced together and react. So Thomson Scattering is really going to help us find that perfect recipe on SD40 to start with, and then going forwards to our other machines. It's a really exciting time to work in fusion. When I started at Tokamak Energy, you didn't see so much about fusion in the news, whereas now you hear politicians talking about fusion when they're talking about future energy security. It feels like it's a field that's really taking off and coming out of scientific research into a commercial mainstream industry, which is what we all want. We want to commercialize fusion. We want to deliver clean energy to the grid. That's the point of what we're doing. We want it to be affordable. And so it's really exciting to be working in this field at a time when we're experiencing that transition.